Hello, beautiful people. This is part 3 of your Integrated Math 1 Module 16 pre-quiz. We have gone through distance formula. We have gone through midpoint formula in videos part 1 and part 2. So go ahead and watch those if you have any questions about that. In part 3, we're working with transformations. I just want to let you know that we are on campus, so if you hear a loud bell, I apologize in advance. Also, if I make a mistake, I am human, it is bound to happen. Just let me know where my mistake occurs so that way we both can learn from it. All right, beautiful people, let's go ahead and get started. Number 10 has this information above it, so I'm assuming it is important. And we're going to read the directions. Use the following for questions 9 through 10. Triangle ABC maps to triangle A prime, B prime, C prime. So we're going to say prime anytime we see this little mark here. All right, here's your pre-image. Pre-image is your original image, okay? We didn't do anything to it. Now, here is your image. This is after something has happened. We're going to state the rule. So what happened, okay? So the rule is going to be something like something happens to our x's, something happens to our y. So I'm going to look at my pre-image x, and I'm going to look at my image x. I'm going to look at my pre-image x, I'm looking at my image x, and I'm looking for the pattern. What happens in that pattern? I'm looking for pre-image x, and I'm looking for image x. And so in all of them, I'm noticing it goes to 7 to negative, 7, -4 to 4, and 5 to -5. So my pattern is I'm actually being multiplied by -1 on my x's. Now I'm looking for y's. So now I'm looking for the pattern of y. I have a 2 and I go to, I have a -2, I go to -2. I have a 4, I go to 4. I have a 4 and I go to 4. So nothing really happens to y, so we're going to leave y alone. So state the rule. We have -x, comma, y is our rule. Okay. All right, so is this a rigid motion? Okay, rigid motion. So this is kind of testing you on your terminology. Do you know what a rigid motion is? Okay. And how do you know? How do you know? So a non-rigid motion, meaning there is a dilation or a compression, meaning the size changes of the image. So if you have a pre-image that is one size, when you go to the image, when you do something to it, that means it has gone either bigger, smaller, the shape has changed, something is going on. Now, if it is rigid, that means you take the original, you pick it up, you move it around, but the original image, which is called the pre-image, doesn't actually change its shape. It doesn't change its size. So how do we know if this is the same thing or not? Well, you can always graph it. You can always graph it. But then just to let you know, without graphing it, if you're not being multiplied, okay, keyword here is multiplication. If you're not multiplying by something, then you are okay. I'm actually going to cheat a little bit, and I'm going to look up the formal definition. So that way I can tell you what the formal. It says a rigid motion is otherwise known as a rigid transformation and occurs when a point or object is moved, but the size and shape remain the same. Okay, just like I said, size and shape has to stay the same in a rigid motion. If it changes its size or changes its shape, it is considered non-rigid. Okay, a dilation when you get something bigger, or a increase or a decrease, that is when it is a non-rigid, okay? All right, so how do we know? How do we know if it is a rigid or a non-rigid when we're just looking at these? Again, you can always graph it. You can always graph it. But in this case, let's graph it. Why not? We can graph it. So we have 7 and negative 2. 1, 2, 3, 4, 5, 6, 7. 7 and negative 2 is here. Then we have negative 4 and 4. 1, 2, 3, 4. Then we have 5. 1, 2, 3, 4, 5, and 4. So that's our triangle here. Looks something like that. And then let's graph the other one. So we have negative 7. 1, 2, 3, 4, 5, 6, 7, and negative 2. Oh, do you guys see that? I kind of combined it. So I see negative 7 and 2. That should be this point here. 1, 2, 3, 4, 5, 6, 7. This is the original. This is the pre-image. So that was my mistake. And then we have 1, 2, 3, 4, and 4. And then we have 5. Yeah, okay. So this is our transformed, and this is our original. So it looks like the size didn't change. So again, what changes is multiplication with a number, like times 2, times 3, times negative 5. So is this a rigid motion? Yes, it is rigid. How do you know? Because size and shape is the same. All right, let's move on to number 11. Draw the image, so again, after it's been transformed, of triangle DEF under the transformation. So here's your rule. So this is what happens to your X values. This is what happens to your Y values. So you're going to do a T-chart. Here is your X prime. Here's your Y prime. And I actually did my table a little bit off-centered. So let's put this line here. Okay. So here are your original points. Take your original points and something's going to happen to it. Okay, your original point, let me undo this. You guys, I apologize for this. Let me undo this. Let me undo this. Let's start with our points. So we have D at 1 and 1, 2, 3. We have E at 1, 2, 3, negative 3. We have F at 1, 2, 3, 1, 2, 3. So negative 3, negative 3. Okay. List your points, then apply the transformation. So what happens to X? Here's your X value, your original X value. It gets multiplied by 1/2. Y stays the same. Here's your X value. It gets multiplied by 1/2. Y stays the same. Here's your X value. Gets multiplied by 1/2. Y stays the same. So again, our D prime is now 1/2, 3. Our E prime is now 3/2, negative 3. And our F prime is now negative 3/2, negative 3. So it doesn't tell you, oh, it does. It just says draw the image. So we're gonna plot these points. So positive 1/2, up 3. 1, 2, 3. We're here. Then we're saying 3/2. 3/2 is the same thing as 1.5. So we're saying 1.5, 1 and a little bit, and we go down 3. 1, 2, 3. Then we're saying negative 1 and a little bit, 1.5, and we're down 3. So here's our image. Again, this is after the transformation has happened. So now we're answering number 12. Using the figure in number 11, is this a rigid transformation? Remember, a rigid keeps the shape and the size. So it is not rigid because the size and kind of the shape, size and shape changes. So this is a little bit like longer, so it looks completely different. So it is non-rigid. You can say not rigid, non-rigid. Okay, let's move on. If in figure angle 1 is equal to angle 2 and angle 2 is equal to angle 3, which property can be used to reason that angle 1 is angle 3? I'm going to circle that one. We're going to come back to that one. We're going to spend more time in it. But don't worry about that one. I circled it. We will mention that in class. Let's move on to number 14. For the figure measure of angle JKL, so the measure of angle JKL, all of this is equal to 63 degrees. Which theorem or postulate can be used to determine the measure of MKL? So we're trying to find this one here if we know this one. And so which theorem? This one's going to be the angle addition postulate. It's very similar to the segment addition postulate. What that means is you take your two little angles or however many angles you have on the inside, you add them together, you equal it to the total large angle. What is the measure of angle MKL? So we're trying to figure this one out. So you're taking your two little ones, so 3x plus 6, and adding it together, and you're equaling it to the big angle. In this case, they told us the big angle is 63 degrees. Combine like terms, 6, 7, 8. I have 8 x's, and I have plus 18, 6, 7, 8, 18 is equal to 63. I'm going to subtract 18 both sides. 8x is equal to, we're going to figure out what 63 minus 18 is, and that is 45. So that means x is equal to, let's see, 45 divided by 8. Let's see here. Did I do something wrong? Let's double check. It's not giving me a pretty number, and I was hoping for a pretty number. So 6, 7, 8. Ooh, did you catch that? I need to learn how to count. This is 9. 6, 7, 8, 9. This should be 9. This should be 9, and then this is 5. I can do math. So x is 5. So again, reread the directions. This is what is the measure of angle MKL. So the measure of angle MKL is equal to 5 degrees. This is your answer. This is your answer. Not this. They didn't ask what solve for x. So this is not the answer. All right. If you live in Sacramento, then you live in California. So what is the hypothesis? Hypothesis. Let's see if I can say that right 5 times. Hypothesis. Okay, of this statement. Okay, so basically what are we thinking? So this is an if and then statement. So if something happens, then something else happens, and then you have the converse of that statement. So the hypothesis is that if you live in Sacramento, then you live in California. What is the hypothesis? That if you live in Sacramento, then California. It's like, what's your guess? Well, my guess is if you live in Sacramento, then you have to live in California. That's my guess. What is the conclusion of the statement? The conclusion is in the statement is then you live in California. Now I'm going to go back on this one, and I'm going to say the hypothesis is if you live in Sacramento. I think they split this up. So if you live in Sac, and then what's your conclusion? Then you live in California. Write the converse of the statement. So we're gonna switch. So write the converse of the statement. Converse means you take your take your if and switch places. So then if you live in California, then you live in Sac. So determine whether the converse is true or false. So is this right here a true or false statement? This is a false statement because if you can live anywhere else. So example, if you live in California, you can also live in a different city. So that's your explanation. Like, why is it not true? It's because you can live in any other different city other than Sacramento. Just because you're in California doesn't mean you have to live in Sacramento. All right, guys, that concludes our Module 16 pre-quiz. You should have pre-quiz number 1 in your possession if you're in my class, and then that way you can follow along with pre-test number 2. It's very similar questions. If you notice a mistake that I didn't catch, please let me know. Again, I apologize for some of the hiccups in this video. But thank you for watching. Take care.